Greetings, ladies and gentlemen. This is Dr. Derek Ong with the next series of videos to help in conducting statistical analysis using SPSS. In this video, I'm going to be showing you how to do repeated measures of ANOVA, one-way, two-way, and split mix design, and what are the things that we need to report. So basically, repeated measures means that the responses from the same respondents are recorded more than twice. So if you remember in the repeated measures in the uh, paired sample t-test, we basically took responses from the individuals twice. So imagine if we had to take it more than 2 times. So how do we look at the differences? So for example, let's say if we have a one-way repeated measures, you may want to see if there are difference in motivation of levels of employees pre, during, and post restructuring period for a company. If it's in a two-way, you probably might want to see if there are differences of likability between type of ad and package design used. Each, of course, are randomly assigned to avoid a spillover effect, so each respondent is given 9 responses. The package 1 using advert 1, package 1 using advert 2, package 1 using advert 3, and so on and so forth, until you see package 3 with advert 3. So to avoid the spillover effects, every single respondent is of course randomized in terms of the kind of exposure they get. And in a mixed design, you may want to see if there are difference in fixed effects, let's say gender, and also over time effects. That's the repeated measures. This is where we have the mixed design, satisfaction levels pre, during, and post restructuring period. Now, let us now go to what we need to report. Now, there are 3 things we need to see. One is, of course, the Wilks lambda to check if there are interaction among the multivariate data, because if we have 3 time periods, we want to see if there are differences among the means of these multivariates. Markley to test for the assumption of sphericity. Basically, the assumption of sphericity is to say that the 3 time periods, for example, has the assumption that their covariances are the same. So if their covariances are not the same, then you might have to use a different test or a different uh, valid data measure to say whether they are different or not. Okay, so some here that I'm going to use is of course the human felt, but we'll look later. And finally, of course, is within the subject's effect if there was a difference over time. So this is the main thing that we want to look at. So now let's look into our data. For a one-way repeated measure, this is our data. We are going to see if there's going to be a difference in motivation levels pre, during, and post restructuring period. So here we go. Our data is such. We're going to go to Analyze, General Linear Model, use the repeated measures. It's always good to put a name with this factor, so I'm going to call it motivation, motive for short. And of course, there are 3 levels to this, so I'm going to add, define, motivation pre as the first factor, motivation during as the second, and motivation post as the third. I'm going to go straight to plots. I want to see horizontally how the motivation levels work. Sorry, we'll skip post hoc. Go to options, check on the display means for the main effects, take the descriptives, effect size, and observe power, and then continue. And press OK. So what we need to transfer here is to look at the different means of the 3 time periods, as well as the multivariate test. Just look at Wilks lambda is significant, so there is a significant difference between the 3 time periods in terms of their means. Markley test of sphericity, if you notice, is significant, which means we reject the null hypothesis of equality of variances among the three. And of course, test within subjects. Usually, if we do not assume sphericity, we try to use something that is less of conservative. So we use Hunefeld, and we report the F41.424 and significant. So with 1.2, usually we just use the 2, and 58 as the F. So if we look at the thing here, report the Wilks lambda, we say there is a significant over difference of the three variables. Mauchly's test of sphericity with chi-square. And of course, the sphericity is not assumed, so therefore we use the Hunefeld. F235, as you can see here. F2, sorry, it's 58. Can change this. And of course, there's significant difference between the times. So this is your one-way repeated measures. Now going on, we can also add in the graph to show that there is a difference, between the graphs, between the time periods. Now moving on, if let's say we have two-way repeated measures, for example, we want to see if ads and packages there are significant differences. So in a two-way repeated measures here, each of our respondents are given 9 types of packages and with different types of advertisements. So we want to see if there's differences between the packages and the advertisements. So please note that to avoid the spillover effect, that everyone is randomized in terms of giving the advert type and also the combination of the package. So we have two things that we want to look at here, whether there's a difference between package, whether there's a difference between advert time, and whether there's a difference in terms of the interaction. So we go to Analyze, General Linear Model, Repeated Measures. So we better give something that is very understandable. So the first one we got to go is package, which of course has 3 levels, add. And the second one is advert, which again has 3 levels, add. So define. So you know that package 1 and advert 1 would be the first. Package 1 and advert 2 will be the second. So really it depends on how you set up your design. So make sure your design is set up so well enough so that you know which one you are supposed to find differences for. So I'm just going to continue on with this. Package 2, advert 1, package 2, advert 2, package 2, advert 3, package 3, advert 1, package 3, advert 2, package 3, advert 3. Right? Go to plots. We take the package and the advert on the separate lines. It really depends on, doesn't matter which one you go, just make sure you go and add. No need for post hoc, we just go straight to options. Look at the display means, compare effects, and take the descriptive estimates and observe power. We might want to also look at the homogeneity test, but of course, most people really just ignore this, but we just to see if we don't violate any assumptions of homogeneity. Yeah? Oh, finally forgot one more. And just press OK. So here in the results, you can see a few things. It says here homogeneity results because there are no between subject factors, because all our factors that we're using is actually time ordered, so there's no in between, right? It's only when we have a between subject factor that is more than 2 levels, then probably we'll probably see that in the mixed design. So we have the separate means for each of the combination, the multivariate statistics to see whether or not there's differences among the for package you have 3 packages, and for AdWord you have 3 AdWords. Notice that only AdWord is significant and package is not significant. Look at the Bix lambda. And for interaction, it is significant. So remember to use the hypothesis test degree of freedom and the error properly as you put in here in terms of Bix lambda. Okay. And now we go to Mauchly's. If you look at Mauchly's, only package and the interaction is test of sphericity, but AdWord is not test of sphericity. That means it's not assumed the variances are equal. So hence, we go to Hunefeld, and we use Hunefeld for the AdWord because sphericity is assumed. But for package and for the interaction, we use Hunefeld. So 5.322, 102.449, and of course 40.952, using each individual errors. So the errors of the degree of freedom will be 258, 258, and 4116. And of course, we have here. So this tells us that there is a difference among the packages, there is a difference among the AdWords, and there is a difference among all 9 interactions. Okay. Next, we also look at the graph for the estimated marginal means of the repeated measures. Now, we move on to split mix design. In a split mix design, we might want to see satisfaction levels pre, during, and post restructuring period. And we also want to see whether there are differences between the gender. So we look at the gender here. Sorry, gender was, it's 2. Okay, so now we go to analyze, general linear model, repeated measures, reset everything. So we're going to put into satisfaction as the 3 levels, add, satisfaction level pre, satisfaction level during, and satisfaction level post. And we're going to put sex as the between subject factors. Plots, we put the satisfaction level here with the sex as separate lines, and add. Post, nothing there. Options, we're going to put in the options for all 3 to display means. Again, check on the homogeneity of tests because we have sex now as a between factors. Press OK, and looking at the output, we have the means, we have the multivariate test. Now the multivariate test shows that there is significant multivariate between the satisfaction as well as satisfaction versus test, so this is between, so we put it there, satisfaction, test, and of course interaction. Interaction is not significant, so that's not significant, it's only significant at satisfaction. Mauchly's test of sphericity, because there's more than 2, so there are 3 time periods, so therefore sphericity is assumed, so it's 0.149 for the satisfaction level. Test within subjects, we want to look at satisfaction, it's significant, interaction, they're not significant. Okay? Interaction. Sorry. Looked at the wrong one. 2.977. This is 2.977. 2.977. It's not significant. Chi-square for Mauchly. Not significant for this one. And it is significant for the F. So finally, we look at the test between subjects, which is the sex. Very important. We find here that it is not significant within sex. So here is not Wilks lambda, it's actually the F-test between the groups. So make sure you put in the correct F-test between the groups. So it's F128. Yeah, F128. Just checking something. So test within subjects, you have F256 and 256. So we are right, F256, 256. So how we derive this is that there is difference in terms of satisfaction, but there's no difference in terms of interaction, and also between sex. So there's only difference between satisfaction levels. And of course, again, you can put in the graph to show the differences between the male and females, as well as the graph for the satisfaction levels. Okay, so that is repeated measures. So if you have any questions, please email me. If not, thank you for watching.